What's up, you freaking geniuses? So in this video, I'm going to teach you how to identify polynomial functions, write them in standard form, and identify their degree, their type, and their leading coefficient. All right, so first of all, let's just talk about the 5 main degrees or types of polynomial functions that you'll see, okay? So there's a small example of each one right here. So let's start with this one at the top. F of x is equal to 5, right? So if you want to find the degree of this function, the degree just has to do with your exponents on your variable bases, okay? So here, we don't have a variable base, right? We don't have an x or something like that right there, right? So there's no exponent, so the degree would be 0. And this type of function is known as a constant function. And it's called a constant function because literally there's just a constant, right? There's just a number. Now, this next one, f of x is equal to 5x, you can see we do have a variable base. What's the exponent on this guy? Well, there's basically just like a hidden 1 right there, right? So the degree in this case would be 1, right? And this is known as a linear function. Next is f of x is equal to 5x squared plus 1. Here we have two terms, right? We have this 5x squared and we have this 1. So to find the degree, you just look for the biggest exponent. Well, 1 doesn't have an exponent on it, but here we have a 2, right? So the degree here would be 2. Okay, and this is known as a quadratic function, right? This one is f of x is equal to negative 7x cubed plus x, right? So again, to find the degree, you just want to look for the biggest exponent. So here we have a 3, so the degree, well, just to clarify, here we have a 3, right? And then x over here basically still has like a hidden 1 on it, but the degree refers to the biggest exponent, so in this case it'd be a 3, right? So 3 right there. And this is known as a cubic function, all right? And then lastly, f of x is equal to 10x to the 4th minus x squared. The degree in this case would be a 4, right? That's the biggest exponent that we have here, so that's a 4. And this is known as a quartic polynomial function, okay? And now there's two clarifications we need to make to identify polynomial functions, and those are up here. So first of all, let's talk about the coefficients. So all your coefficients, they can be any number, doesn't matter what number, it could be positive, negative, whatever, they just can't be 0. And the other thing are the exponents, right? So all your exponents have to be whole numbers, or sometimes they're called counting numbers. So 0, 1, 2, 3, 4, right, etc. So no negative numbers, no fractions, nothing like that, just whole numbers, okay? So with that in mind, let's go over just a few more examples that are going to be just a little bit more complicated. All right, so let's scroll down here. All right, I know they look way more complicated. So let's start at the top. So here we have f of x is equal to negative 2x cubed plus 5x plus 8 minus x squared, okay? So first of all, do all of our terms qualify or pass those two additional checkpoints, I guess? So we can call this a polynomial function. Well, again, the first thing you want to look at are the leading coefficients. They're all real numbers, right? We have a negative 2 here, positive 5. This is just a constant by itself, plus 8, that's fine. And here we have a negative, basically 1, right? So all the coefficients are good. What about the exponents? Are they all whole numbers? Yes, they are, right? Here we have a 3, here we have a 2, right? They're both positive, and we also have this additional 1 right there, right? So all 4 of these terms check out. So if we want to write this, first of all, in standard form, you just list all your terms by the exponent, and you always put the biggest ones first, and then the smallest ones at the end, all right? So basically descending order. So if we want to rewrite this in standard form, it would be f of x is equal to, the biggest exponent here we have is 3, right? So that's going to go first, negative 2x cubed. The next one would be this one, right? Negative x squared, so minus x squared. Then this one right here, right? Plus 5x. And then the constants, the numbers, they always go at the very end. So plus 8, right? So now this is written in standard form, okay? Now the 3 things we need to identify are the degree, the type, and the leading coefficient. So the degree, again, is just your biggest exponent. So here it's 3, right? So that means the degree is equal to 3. Remember, whenever your degree is 3, that means it's a cubic function. Okay, so cubic is the type. And then what's the leading coefficient? So the leading coefficient is just the coefficient on your first term. Or in other words, the term that has the biggest exponent on it. Okay, so that would be this term right here, right? This term has the biggest exponent on it. The leading coefficient here is -2. So the leading coefficient, again, is -2. Okay, cool, not too bad, right? So let's just do a couple more. So here's g of x is equal to -0.8x cubed plus √2x to the fourth minus 12. Okay, so first of all, do each of these three terms pass our test? The coefficients are -0.8, positive √2, and then just a constant -12, right? So again, your coefficients can be any number, positive or negative. So decimals, fractions, square roots, these are all good. And the other thing we want to look at are the exponents, right? So they're whole numbers, right? This is a +3, that's a +4, so those are good, okay? So now that we've checked all that, now we can write it in standard form. So again, in descending order with with the exponents from largest to smallest. So this is going to be g of x is equal to, and then we're going to go with this one first, right? So positive √2 x to the fourth, and then this one's next, so minus 0.8 x cubed, and then minus 12. Okay, so now that it's written in standard form, again, we can find the degree, the type, and the leading coefficient. So the degree here looks like it'd be a 4, so that means it's quartic. Man, that's a little hard to say, isn't it? And then the leading coefficient, again, is just the coefficient on whatever term has the biggest exponent. So again, that would just be our first term right here. So it's a square root of 2, right? √2. There's your leading coefficient. Okay, and the last one right here, h of x is equal to -x squared plus 7x raised to the -2 plus 5 over x squared plus 2x to the fourth over 9 plus 3 to the x. Wow, a lot of ugly stuff here. So again, let's check each of our terms to see if they pass. So first of all, -x squared, that's fine, right? Because we basically have a -1 right here, so the coefficient's fine, and we have a positive exponent. Here, 7x to the -2, 7 is good, but -2, that's no good, right? No bueno, can't have a negative exponent. So since this term right here fails, that means this whole thing is not a polynomial function, okay? So that one's no good. But let's check these last few terms, just so you know what to do in case you come across something that's kind of similar, all right? So first of all, 5 over x squared. Well, let's compare. So here we have 5 over x squared, so we have an x in the denominator. But here, 2x to the fourth over 9, we have an x in the numerator, right? So this one doesn't work, but this one does work. So let me explain why. Having an x in the denominator is the same thing as having a negative exponent, okay? Because 7x squared, I can rewrite that. If I factor out the 7, right, this is the same thing as 7 times x to the -2. Now, how do you deal with a negative exponent? Well, maybe it'd be a little easier to see it with a number, right? So if I had, for example, 5 raised to the -2, in order to evaluate this, this is the same thing as 1 over, and then you just put this whole thing in the denominator. You just make the exponent positive, right? So 1 over 5 squared, all right? So same thing over here, x to the -2 would be 1 over x squared, okay? Now, going back to 5 over x squared, if I factor out the 5 from the top, then this would be the same thing as 5 times 1 over x squared. So, as you can see, we have the same term, right? 1 over x squared, 1 over x squared. So 5 over x squared, I could rewrite that as 5x raised to the -2. Okay, but in either case, the negative exponents don't work, right? So that's why we can't have a variable in the denominator like that. Now, we can have it in the numerator here because 2x to the fourth over 9, if you just factored out the numbers, basically this fraction right here, the 2/9 from the whole thing, then this would be the same thing as 2/9 times x to the fourth, right? And so this is now the coefficient on our term, and 2/9 is just a fraction, right? And our coefficient can be any number, just not 0. So 2/9 x to the fourth definitely works, okay? And then this last term right here, 3 to the x, well, this obviously fails because our exponent is not even a number, let alone a whole number. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.